So good morning, everyone. I'm Vijay. Please speak in the mic. I'm Vijay Nadkarni, and I'm at Visteon. My role at Visteon is responsibility over AI and also augmented reality, and that is basically for three different areas. One is autonomous driving. We actually are developing a platform for AD, autonomous driving. I'll talk about that. And in addition to that, I also am responsible for the AI technology for infotainment, as well as for augmented reality. Now, many of you may or may not be aware of this, but essentially on Monday, which is the day after tomorrow, there will be, in the US alone, there will be 385 million gallons of gasoline that will be consumed in people's daily commutes, of which about 100 million gallons will be because of traffic congestion. And think of that, that's basically 100 million gallons of fuel going up into the air that does not necessarily need to be. And that is something that autonomous driving can actually avoid. In the short talk that I am having right now, there'll be about 23 people worldwide that will essentially lose their lives in traffic accidents. Think of that. And that's about equates to about 1.2 million people per year that will die due to traffic accidents. So let's talk a little bit about why we need autonomous driving. So the first thing is productivity. Almost all of us, or many of us, most of us I should say, spend a lot of time in our cars or commuting to work. That is time that we could be spending essentially doing more productive stuff like doing emails, for example, or talking on the phone, or in conference calls. Some of that is possible today, but you're fiddled with your phone. You're not really supposed to do that. But productivity is something that is important. When I go to work, I really want to have an awareness or understanding of what I'll be doing and not necessarily stuck in traffic. The second thing is safety. I just mentioned a few stats there, but essentially there are a lot of people around the world that die that don't need to. Accidents, motor vehicle accidents are actually the leading cause of death among people who are less than 35 years. That's a pretty frightening thing, and it's something that can be prevented or at least improved radically. So safety is a big need in the industry right now. The third is mobility for those who cannot drive. So there are lots of people around. They could be the elderly who are essentially just unable to drive because they simply are too old to, yet they need to go somewhere. And they cannot, getting a taxi all the time sometimes is a little tricky. Or it could be young kids. Almost many of us essentially are faced with, when we come back from work, we have to take our kids to the local math class or maybe a soccer game or something like that. Think of how that could be done if you have autonomous vehicles instead. Also, reduction of the commute times and pollution. The two, of course, go hand in hand. But that is, again, something which autonomous driving can and will improve radically. And again, that is a big motivator because that essentially will reduce the amount of frustration that all of us face just simply going to work and back or stuck in traffic. So in autonomous driving, there are basically three separate things that come to the picture. The first is recognition of the environment. You have essentially a vehicle, and for the vehicle to do anything at all, it needs to really know what is around it. It needs to know where the cars are. It needs to know what road surfaces it can drive on. It needs to know about the pedestrian that is about to cross the road or on the road, things like that. You need an awareness, or you need to have a recognition of the environment. Without it, nothing else can happen. I mean, that's sort of the building block, the first building block of autonomous driving. But knowing that alone doesn't solve the problem. That is just one thing that needs to be done. Once you know what the environment is, you really need to know how to act on the environment. What do you do with that knowledge? And that is basically what you do with this fancy term that we call path planning. And path planning is basically a very, I would say, the automotive kind of term for the vehicle performing certain maneuvers. These maneuvers could be stopping at a traffic light. It could be possibly making a turn at an intersection. It could be changing a lane on the highway, any of the above. But it is the things that we basically do ourselves as drivers when we are in the car, and that is essentially deciding on which maneuvers to take and executing those maneuvers. But even there, that's not enough necessarily. You may think it is enough, but there's one more thing, which is the roadways. They basically throw at us all kinds of different things that we are not really planning for. It's uncertainty, essentially. And one of the speakers earlier had this really nice video of that intersection, which I thought was really cool. But that is basically what what driving throws at us. This is one of the most difficult things to I would say undertake technologically, at least. But knowing how to handle the uncertainty and knowing how to deal with it is, again, a key thing for autonomous driving to really take off. And once we are able to solve these three things, which of course is happening right now as we speak, then the industry can really take off in a big way. So this is, again, a technology that we use called reinforcement learning. This is basically a vehicular maneuver. This is overtaking. And let me just run through this. Okay. So this is basically on a simulator, obviously. You have a vehicle that is approaching a slower vehicle ahead. It'll see that the adjacent lane is empty. It'll pass the vehicle, and then eventually it'll get back into its original lane. And this is done using this technology called reinforcement learning, which basically means that you essentially subject the vehicle on a simulator to both good and bad situations, literally thousands or tens of thousands, hundreds of thousands of them. You let it learn from those various simulations, and then it eventually figures out how to avoid a bad outcome and how to essentially execute the good outcome. Now, you learn one more thing in this video, which is this is a great example of one more thing that this car has learned, which is to break the rule. Essentially crossing the double yellow line, and that's something that, of course, is not intended, but it's something that the human beings do all the time. But nonetheless, so it's learning true human behavior in multiple ways. Let's talk about where the industry is going from here. So in autonomous driving, it's not obviously a completely rosy picture. It's one of the hardest technologies, in fact, that is being developed right now. And there are many challenges in this, not just a few. Okay, so the challenges are, on the technological side, the last 0.1% of perfection. In this industry, basically, the first 99.9% of the complexity takes, let's say, 99% of the time, and the remaining 0.1% of complexity takes the other 99.9% of the time, or multiplied by 10. So getting to that last 0.1% is extremely difficult, but it's something that there are a lot of new technologies that are being implemented that can actually get us there, and that's essentially what's happening now. The readiness of customers to adopt this technology is not to be taken lightly. If you ask an audience, many of them will say, yeah, I will drive it. I will certainly. They can't wait for the autonomous car, but I can guarantee you that they will think hard before they want to be the first guinea pig to be trying it out. So how many of you will really, when autonomous cars really become available, jump out and go and buy one? There you are. Anyway, so that is the readiness to adopt is clearly a factor. And there are studies done on all this stuff. I'll show you one very soon. Safety is a big thing. Safety is clearly one of the things that is a big promise of the industry, but at the same time, a lot has to be done to make the vehicles safer. One hears everywhere about all these accidents, Uber, Tesla, Google, etc. And these accidents, of course, in terms of sheer numbers or statistics, are not necessarily any worse than what human drivers, is essentially statistics for human drivers. But nonetheless, it's something that gets a lot of publicity, and that publicity throws a lot of fear into people. Certainly, something that has to be I would say, the people need to feel more comfortable with the safety. And then we have regulations. Again, regulations are evolving. The rate at which technology is evolving is much, much higher than the rate at which regulations are coming into the picture. Certainly something that needs to really get more, that the regulatory bodies need to get more active with. Then, of course, affordability. A typical autonomous car today that you may buy from a company that builds one typically will cost roughly about $500,000. I can guarantee you that among most of you here, probably 99% of you here, you're not going to be spending that kind of money for an autonomous car. You really want it to be at the level of today's car prices. So that's a big factor. And then finally, cybersecurity. So I don't know how many of you know of the incident that a couple of hackers, they were just having some fun actually, but about 3 years back, they commandeered a Jeep on the highway. And essentially, they did all kinds of things with that Jeep to essentially prevent it from, they sort of tapped into its drive-by-wire controls and were able to essentially make it accelerate, to turn on the wipers, to do all kinds of crazy things. They were able to actually see the road because the Jeep was exposed to the camera, so they didn't actually crash it. They could have, but they didn't crash it. But they really played havoc with the driver that was in the Jeep at the time. You want to avoid that sort of thing. You don't want people, and this is again just a fun thing that they did. I mean, they were actually playing a prank. But this could be very easily in the hands of terrorists or whoever it is. This could essentially be a weapon of destruction. So you want to be very, very careful with that. So a quick show of hands. Among these, let's say these 6 things, how many of you think that the last 10%, the 0.1% is the hardest thing? And readiness to adopt? Okay, how about the same? Safety? Okay, probably more people for safety. Regulations? Okay. Affordability? Okay, more hands for that. And cybersecurity? Okay, a lot of you for cybersecurity. Amazing. Okay, so this is a study that was done. And again, this is a scientific study, but this is across the population at large. It actually shows that the top concern among people is safety. And I think I did see a lot of hands for safety over here. The second most is actually the readiness to adopt. That is the second. And the third is the capabilities of the technology. Sorry, not capabilities, it's a lack of regulatory framework. So a lot of people believe that without regulations, this is not necessarily just safety regulation. This could be, for insurance, for example, when an accident happens, who's at fault, things like that, and so on. But anyway, this is essentially a sampling of what the industry has to overcome before autonomous cars get on the road. It's not just the technology, but it's a lot of other stuff along with it. And then unless this is, I would say, unless the industry gears itself for this, it may be a bit of a hard road. Fortunately, the industry is aware of all these things. It's not like a brand new discovery. And each of these is very, very actively being addressed today. Finally, to wrap up, what will make autonomous driving really take off? I mean, what is coming on the horizon in autonomous driving? So the first thing is there are some really and truly amazing AI technologies in the mix. The one that I think has a huge future here is adversarial reinforcement learning. In this, what you basically have is an agent, which is it's like a good agent that is essentially doing all the right things and is executing the maneuvers. And then you have a bad agent, which is also a reinforcement learning agent, whose task is to do nothing but throw impediments in the good agent's path. So they're very adversarial, and essentially what happens here is that the good agent makes the bad agent better, the bad agent makes a good agent better, and essentially they are able to train off each other and become much, much, much better. This is something which essentially has a lot of promise. It's a very, very actively researched area in the industry right now. The second is capsule networks. That is essentially the ability to handle many of the things that current convolutional neural networks have difficulty with, things like scaling of object, rotation, tilting, things like that. And then, of course, you have the data generation. Today, I think you might know that to get data, you have to be in an automobile getting hundreds of hours of driving data, and then somebody has to label all that data. And in this, essentially, one can label the data pretty much automatically and create it automatically. The second thing is you'll start to see a lot of what I call level 4 applications on the market. In fact, I think trucking is going to be a big one. We already have 2 speakers talking about that. But trucking or long-distance transportation, I think, is a big, big industry. I personally believe that that will be probably the first area that will really start to take off. Obviously, you have other things like shuttle driving around airports or in campuses and such. And oops. Finally, what you will see is a fairly comprehensive set of regulations coming into the picture, and these could be essentially safety regulations. They could be regulations for discovering fault when an accident occurs. These could be regulations for certifications. All of these are basically things that will happen pretty soon, and all these will essentially are enablers of the industry going forward. And with that, thank you.